as you take any programming language, it needs a lot of packages or header files or some libraries imported into the code. So what this does is, like in Python you have not many packages like this import rpi.gpio. But you may not need all the header files loaded together, and as per tailor-made applications, what are the stuff you need, you can just import it as per the needs for you. Then you need to import those library functions, and then you can use it in your code. So here in Python, for this using this robotic applications, we are importing only one header file, that is this import rpa.gpio as gpio. That is for the input and output of this robotic vehicle. Then you are using an error catching, that is try catch error, which is normally used for error handling. If there is any problem in importing this rpa.gpio, then you are trying the try module and then giving an exception of runtime error and showing like there is a problem in loading or importing this package. So mostly this will be done using the pseudo user in Linux. So then the commands you have, like you can set GPIO pins, whether they are the input or output, the pin number is true or not, or pin number for input, which are the pins which you need to set for the input and which are the pins you need to set for the output. So these are the configuration numbers which you need to give initially to set up the GPIO connectivity between the robotic vehicle and the Raspberry Pi console. And this is the beginning of coding. You're just using this try catch exception handling, like you're trying to import this rpi.gpio and then you are having like exception of runtime error to print the error of importing this GPIO part. This must be run using this sudo, and then you are setting some kind of terminals using the files and some sort of file numbers which you need to give as input, where you need to store all the data of the tracking. And here the next one, after this initialization, you are setting this motor I1A and 1B corresponds to the left wheel, and motor 2A and 2B corresponds to the wheel which is in the right. So this 17 and the 18 in the GPIO pin is set to the motor 1A and 1B, that is for the left wheel to move forward or reverse. You are setting it to pins 17 and the 18 in the GPIO console. Motor 2A and 2B has the pins 23 and 22 concerned with the right forward and right reverse, which is for the moving the right wheel forward or reverse. And then you are setting the frequency of outputs. In what frequency? You are setting like 50 Hertz as the frequency for the output for the power module. It uses a processor pin numbering, and you are setting the set mode GPIO.set mode of GPIO.BCM. So this is the processor which you are using. So it is setting the mode for this particular processor. And then you are setting the speed, as you all already know, like it's 50 Hertz or 50 cycle you are doing. And then the direction number keys. You know, the number keys will be like the number pad you are having, and you are setting like each and every number for each and every direction. So those keys are set for the values, like number 1 key is set to 2, 0, 2, 2 is for 2, and the 3 gets 0 and 2, like that up to 0, 1. You have all these set together. And similarly, you have like the keyboard keys. You have the keys R, T, Y, F. These all form like a nearby one. So it is like you can set the keyboard keys also. It doesn't mean that it should be only R. You can make A, S, D, F instead of this R, T, Y, F, and then you can set like some other characters here. Whatever you want, that you can set the keyboard configurations here. And the initial setup should be like the direction of the vehicle should be 0 0, that is it has to come to the initial position, so that you are mentioning like current underscore direction equal to 0 comma 0, so it will be in the initial situation. Then you are setting up the pins GPIO dot setup motor 1A comma GPIO dot out. Motor IA you are already mentioned like 17 the pin and 18 the pin for the motor 1A and 1B. So you are setting this GPIO setup motor IA means 17 and the 18 are set for this input, and motor 2A and 2B 23 and the 22 pins are set for this right one, right movement forward and right movement backward. And setting the pins as PWM pin 1A, you are setting like the frequency of how the output has to be given. So these are all given in pin 1A, pin 1B, 2A and 2B. So you are starting the motor, it has to start at all zeros. Initially it has to be at zeros, and then for forward it has to move the direction forward, so that should be incremented each and every time. So this is the whole long coding which you cannot explain within the stipulated time, but after making all the coding necessary for the key events, right from the number keys or the character keys, you are just setting like pin A dot change dot duty cycle of 0, or the speed you are changing, and the direction. So each and every changes you are making here based on the key press events. So then again after finishing, then you are stopping each and every pin 1A and 1B, that is the left wheel, that is the stepper motor in the left, pin 2A and the 2B which corresponds to the stepper motor in the right, and finally this GPIO is cleaned up and reset. So the interface input for using the character, I have already mentioned like RTYM, HCVB. This is for the characters, and fast P and L. So similarly, when you use number keys, you can use like all these whole number keys and the plus and minus for decreasing the speed and increasing and decreasing the speed respectively. So this is the interface input which we have set for this robot, and we can make more modifications, and we can bring more innovations with this kind of Raspberry Pi and robotic kind of applications. So this is all about a sample of my teaching methodology in this kind of research projects. Thank you so much. Kapkuna Kap.